So good morning everybody, welcome to Water Resources Engineering class. So we have completed two units. The first unit covering mainly the hydrologic cycle and precipitation, whereas the second unit we covered the abstractions from precipitation, in the sense that all the other components of the hydrologic cycle, be it evaporation, evapotranspiration, infiltration, surface runoff, depression storage, watershed leakage. So all those we have completed in the second unit. So now we are continuing with that runoff and moving to the third unit. The starting point for the third unit is runoff only. Only in the second unit we have covered what is runoff, what are the components of runoff, what are the factors affecting runoff, what are the methods for estimating runoff. So the third unit mainly we focus on hydrographs, how to develop a hydrograph, then actually what are the unit hydrographs, the synthetic unit hydrographs, S hydrograph, all these analysis part we will see in unit 3. So now let us move to unit 3. If you see what are the contents of unit 3, if you see it, hydrograph, distribution of runoff, hydrograph analysis, flood hydrograph, effective rainfall, base flow separation. So this first lecture consists of that part actually. So I will take that part first. But before taking that part, I request every one of you, please focus on what is the outcome expected from this unit. When you are studying this unit, what is the outcome that is expected? The outcomes in terms of various Bloom's levels. Some of them may be explaining things, direct, straight. Some of them may be analyzing the things, that is a little bit higher order. Some of them may be basically you need to create yourself and then discuss. So these are the what are the aspects that which we come across in this particular unit. If you see the course outcome 3, understand the concept and components of hydrograph almost at level 1 only. And again then the runoff distribution, separation of the base flow, calculation of the effective rainfall, that is L2. Apply the techniques of for base flow separation and construct direct runoff hydrographs and unit hydrographs at Bloom's level 3. And then analyze and derive unit hydrograph, S hydrograph, synthetic unit hydrographs for hydrologic modeling and interpret them. So that is at L4 level. So different levels, what type of things that are expected from you while studying this particular unit you should know. As usual, what are the textbooks that which we have followed, what are the reference books which we have to look into for this particular unit. I specified like any other unit, but there are 3 books which additional reading which we have to do for this particular unit that I mentioned at the end of this lecture. Kindly go through those books also before really you take it up this particular unit. So mainly today's lecture focuses on number 1, what is hydrograph, and distribution of runoff, how we express it. And hydrograph analysis and what do you mean by a flood hydrograph? Let us talk first what is hydrograph. A hydrograph is just a graphical representation. Fine? It's a graphical representation. Just simple. It's a graphical representation. What it shows on x-axis, what it shows on y-axis. It shows time on the x-axis. It shows the discharge on y-axis. Again, remember, it shows the time on x-axis and it shows the discharge. Discharge means flow rate. It is in meter cube per second. It shows on y-axis. So, it's how discharge in a river or a stream varies over time at a specific location. At a specified location, how the discharge versus time varies. We take an outlet point of a stream and at that outlet if you start gauging it, measuring it with time, how the discharge varies, that is what we call it as hydrograph. Again remember, on x-axis we take it, actually this is x-axis, this is y-axis, x-axis is time, y-axis is discharge. Discharge means actually it is flow rate. What is the use of this hydrograph? Okay, we will plot. What is the use of it? Number one, if you want to analyze the flood, fundamentally you require the hydrograph. And in the flood analysis also, what for? I have given here to understand the peak discharge, the maximum discharge, how much will be and how much time it takes to reach to that peak. If suppose when you see the hydrograph, this is how hydrograph looks like. So how the discharge is varying. So how much is the peak? And after this peak, how much from the beginning, how much time it takes to reach the peak? That is the next. And what is the duration of the flood? The entire flood duration is how much? That we can analyze it from the hydrograph. Then second, it is useful in flood forecasting and at the same time floodplain zoning actually, where severe floods occur, where generally medium rate floods or moderate or almost no floods at all. So you can zone the regions also based on hydrograph analysis. If you take all the past hydrographs, then you can analyze the regions and you can forecast also based on the past. That is first thing. The flood analysis, if you want to do it, hydrograph is necessary. Then second is watershed management. When I say watershed management is, so after the rainfall, what is the response? What is the runoff actually? How much water is flowing on the surface of the earth? If that response you want to evaluate clearly, then this particular hydrographs will assist. So for watershed management. So once it assists for that, it also assists for how the drainage system should be, how the reservoirs should be, and what are the measures that which we have to take for soil conservation. So this is what watershed management is. Watershed management means the availability of water, how to really take that water outside systematically, or to store that water, what should we do? These are the things and comes under watershed management. Then third one is urban hydrology. So especially in urban hydrology, stormwater drainage, you want to really analyze properly, you need the hydrographs. That is the third one. Fourth one is hydrologic modeling. Hydrologic modeling means in the sense that the rainfall runoff models, if you want to have it. So for this particular rainfall, this is the runoff. If you want to do that rainfall runoff modeling, you need the hydrographs actually. And any hydraulic structure you want to construct, basically hydrographs are must. And naturally, finally, the environmental studies. So because how the ecosystem is for various river flow patterns, if you want to analyze, you need to study the hydrographs. So what are the factors affecting a storm hydrograph or flood hydrograph? The hydrograph generally available for us is called as storm hydrograph or flood hydrograph. What it is actually, for example, a storm has occurred, maybe a period of 3 hours. So due to that storm, whatever rainfall that has occurred, out of that rainfall, what is the runoff actually? What is the runoff that is flowing in the stream and reaches to the outlet point? So at the outlet point, we measure actually the discharge and with respect to time actually. For every 10 minutes, we measure what is the discharge, what is the time actually. So time versus discharge curve we will prepare. So that is what we call it as storm hydrograph. Due to a storm of 3 hours, 2 hours, 1 hour, that storm, what is the resulting runoff? The resulting runoff from a storm is what we call it as storm hydrograph. That is also, if suppose it is the intensity is very high, then the same thing is also called as just flood hydrograph. So that is the raw thing first. A raw hydrograph means just a storm hydrograph, right? So this storm hydrograph, what are the factors affecting for that storm hydrograph? So there are basically, I classified them under only just 4 headings. What are those 4 headings? Number 1 is basic characteristics. Basin characteristics. Number 2 is infiltration characteristics. Number 3 is channel characteristics. All these 3 comes under physiographic. That means all physical things only. All these basin characteristics, infiltration characteristics and channel characteristics. Physical things. Then the second parameter, climatic factors. The climatic factors are all related to rainfall, evaporation, temperatures, these things actually the second. So kindly remember that finally what are the various factors? Main factors means one is basin characteristics, second one is infiltration characteristics, third one is channel characteristics, fourth one is climatic characteristics. So these are the 4. I will show you in detail how they can be done also. Suppose now I take it basin characteristics. What are the various basin characteristics? I can take it. What is the shape of the basin? What is the area of the basin? Or how the slope of the basin is? How the drainage density is? And how the land use is? Right? What is the storage point? So these are all called as, if you take it, basin area, basin shape, basin slope, drainage density, land use, storage. So these are the 6 points that comes under basin characteristics. How these characteristics affect basically the hydrograph. For example, basin area. Larger basins produce more runoff with delayed peak. So that means if suppose the basin area is short, then the peak will be very quickly it reaches. Whereas if the basin area is large, then naturally from all the areas it has to reach. Already I mentioned in the last class, suppose if you take it, suppose this is the basin for example, right? This is the catchment area. So that now mainstream is, this is the mainstream. And for this mainstream, there will be substreams which are joining actually. So these are all the basically substreams which are joining the mainstream, right? Like that many streams may be there in this catchment. So these are the substreams, right? So all these. So if you see, if suppose the basin is so large actually area, then naturally the water which is at the last point, how much time it takes actually to reach the outlet, if this is how the water flows actually, if you see it. So now if you call it as this is the outlet point. So we are measuring the discharge at this outlet. The discharge versus time at this outlet we have taken. So now you see whatever the rainfall is there in this area, for example, it reaches quickly the outlet actually. So naturally that is next. Suppose if you take it here, this reaches next. So like that, the water from this to reach here, it takes longer time. So that's why it is called as delayed peak. Whereas smaller basins react quickly. That is what the answer is. And basin shape also, if suppose you take it, basin shape is like this. For example, it is what we call it as a fan shaped basin, where this is the outlet. Let us take it, right? So this is the stream. So naturally, if I see such type of basins, right, now fan shape means expanded. So more or less, if I take it, this length is smaller, then this length is smaller, more or less the entire water reaches here at the same time. Rather than this, if suppose the basin is like this, if suppose this is the basin like this is the stream and this is the outlet. So naturally in this stream, if you take it, so for example, how much time it takes from here to here. So the more the length, if you take it, here the length is less. So in the case of a fan shaped thing, normally it reaches more or less the entire water reaches the outlet at the same time. Whereas in the case of fan shaped thing, it reaches a delayed thing actually. So circular basins give sharp peaks, whereas elongated basins produce flatter hydrographs. So this elongated things produce flatter hydrographs. The meaning is, suppose if you take for the circular basins, this will be like this, whereas for this basins actually if you take it, it will be like this actually. So that is the difference what here. Then basin slopes, steep slopes if they are there, they lead to faster runoff and higher discharges. And higher drainage density shortens to the time to peak. So higher the drainage density, that means the area covered by the stream. So that is what we are taking it. So in that case, the rising limb very fast it will rise actually. Whereas urbanized areas cause higher peaks, because in the urbanized areas the runoff will be very, very high, infiltration is very, very less, right? Whereas in the forest, if you take it, naturally the runoff will be very less, more or less most of the things it goes basically into the soil itself. Then natural storage delays and reduces the peak runoff. So these are the factors for basin characteristics. Whereas if I come to infiltration characteristics, there are only two simple things: soil facts, the soil type. If sandy soils are there, more infiltration. If suppose for example clay soils, almost infiltration is impervious soils, so more runoff will be there. The more the runoff, naturally the hydrograph also, the peak will be reaching very fast actually. Whereas if the vegetal cover is there, runoff will be less. When runoff is less, almost it becomes a flat hydrograph. Then antecedent moisture condition means already what is the soil moisture condition. That means if it is already a wet soil, naturally runoff will be very high. If already it is a dry soil, more and more water percolates into the ground, therefore the runoff is less. So because of that, whether the hydrograph rises sharp or flatter or peak reaches fast, so these things depend upon. And land use practices means for what type of purpose for that land is being used. If it is for farming, actually already tilling is being done, then naturally more infiltration will be there, less runoff. Or if it is a walkable area where it is a barren land like, naturally it's already a compacted soil like, so naturally in that case the runoff will be more. The more the runoff, the fast actually it rises the upper limb, the limbs, and it reaches to the peak. Otherwise it becomes a flat hydrograph. Then channel characteristics. What are the channel characteristics? Maybe what can you take it? Maybe for example, channel length, how much it is, and channel slope, how much it is, and what is the type of material in the channel actually, and whether the channel can store some water or not. So these are the factors which are very, very important as far as the channel is concerned. Accordingly, what is its effect on the hydrograph also we have discussed actually. And the last one is the climatic factors. Main climatic factors means what are the climatic factors? Rainfall intensity. The more the intensity, For example, the more the runoff. The more the runoff means the hydrograph basically it will have its peak and it will be a rising thing actually. Whereas rainfall duration, the longer the duration, the lesser the runoff actually. So that is what all factors affecting runoff affect the hydrograph. That's how you should remember. What is the type of the thing? Whether it is a convective precipitation, orographic precipitation, frontal precipitation. Convective precipitation means very high intensity in a short time. So naturally, the sharper peaks you can observe it. Whereas rainfall distribution, if it is distributed uniformly, then naturally you can observe a sharp peak. Otherwise, it will be almost like a flat curve like temperature. Higher the temperature, higher the evapotranspiration, lesser the runoff. So that is one point. Evaporation and wind. So the more the wind naturally, the lesser the runoff actually, because the more the evaporation occurs. So these are the 4 points actually. One is basin characteristics, right? That is first thing you should remember. Second one is what? After the basin characteristics, what you should remember? The second one actually, what is the second one? Infiltration characteristics. Basin characteristics, infiltration characteristics. Then next one is climatic factor, channel characteristics, climatic factors. These are the 4 things on which the shape of the hydrograph, how the hydrograph looks like, it differs actually.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.